Hi there. In our last section, you learned how to find the equations of lines in vector as well as Cartesian form. In this section, you are going to learn how to find the angle between two lines. So let's begin. Angle between two lines. Let P1 and P2 are two lines passes through origin and their direction ratios are A1, B1, C1 and A2, B2, C2 respectively. In order to explain this, what I'm going to do, I'm going to use this information to graph two lines P1 and P2. So this is my graph. As you can see, this is my x-axis. This is my y-axis and this is my z-axis. This point is my origin. This is my first line P1 which passes through origin and this is my line P2 which passes through origin too. And the angle between line P1 and P2 is angle theta. Then the angle theta between the lines is given as cosine theta is equal to absolute value. We also call it mod. So inside the absolute value or mod, we have A1, A2 plus B1, B2 plus C1, C2 over a square root of A1 square plus B1 square plus C1 square. And I also have a square root of A2 square plus B2 square plus C2 square. And this is the angle theta between line P1 and P2. If instead of direction ratios, if the direction cosines of the line P1 and P2 are given and they are L1, M1, N1 and L2, M2, N2 respectively, then the angle theta between line P1 and P2 is given as cosine theta is equal to absolute value or mod L1, L2 plus M1, M2 plus N1, N2. And the sine angle can also be given as sine theta is equal to square root of L1, M2 minus L2, M1 square minus m1 n2 minus n2 n1 square plus n1 l2 minus n2 l1 square. This is how we will find the angle theta when the direction cosines are given. Now what I'm going to do, I'm going to discuss two cases when the lines are parallel and perpendicular. So let's discuss case 1. So case 1 is when the lines are perpendicular. So if theta is 90 degrees, then the lines are perpendicular and then A1, A2 plus B1, B2 plus C1, C2 is equal to 0. In other words, we can also say that if A1, A2 plus B1, B2 plus C1, C2 is 0, then the lines are perpendicular. So what I would suggest, if you have a line with direction cosines are given, then just substitute the value in this expression and see if it's 0, then two lines are perpendicular. Case 2, when the lines are parallel. So if the lines are parallel, theta is 0 and A1 over A2 is equal to B1 over B2 is equal to C1 over C2. In other words, we can say that if you have two lines with direction ratios are given, then you can just substitute the value in this expression and see if the ratios are equal, then it simply means that the lines are parallel. Now, what I'm going to do, I'm going to consider an expression where we are going to consider the Cartesian form of the equation and then we will find the angle between two lines. So if theta is the angle between, this is my first equation, x minus x1 over a1 is equal to y minus y1 over b1 is equal to z minus z1 over c1. And my second equation is x minus x2 over a2 is equal to y minus y2 over b2 is equal to z minus z2 over c2. Then the angle between the lines is given as cosine theta is equal to mod or absolute value a1 a2 plus b1 b2 plus c1 c2 over a square root of a1 square plus b1 square plus c1 square and a square root of a2 square plus b2 square plus c2 square. If you look closely, you will see the expression for the angle between two lines are the same no matter if the line is given in vector form or the line is given in Cartesian form. In other words, we can say that it doesn't matter, we have the same expression for the angle between two lines, whether the lines are given in vector form or Cartesian form.